basically, you've heard so far today about the science and some best practices, and we're just going to take a little bit of time today and share what Iowa producers are actually doing in terms of silage management and silage practices. And this is a project that Russ took leadership on last year. It was a survey of Iowa producers looking at what practices they're doing in terms of silage management, and then we had a subsample of those where we actually got some samples back. So it's not a large sample of like the Dairyland analysis that we saw that was thousands of samples, but this is samples that we felt were representative of the producers that Russ will be sharing the survey data on today. So that's what we intend to do over the next 30 minutes or so. So just a little bit of background. You've seen some of this information already, but this was silage production in Iowa 2017. And you can see, is there a pointer here? You can see that most of the silage production in Iowa is in western Iowa as well as northeast Iowa. And this over here on the right is where the surveys were actually returned from. And so mostly where we have our largest concentration of silage production is in northeast and northwest Iowa. We've got good representation there. And then also north central, and I think that's primarily because that's where Russ's region resides, and so he was able to twist some arms in that region as well. So that's a little bit on silage production in Iowa, but clearly corn silage production, you would expect that to trend with where corn production is, but actually if you look at the ranking of states in terms of corn silage production, you see that a lot of these states that rank high in corn silage production are also high in terms of dairy production. And so a lot higher proportion of their corn is being used as corn silage just because it is, as you've heard all day, that corn silage is a very important feed in terms of dairy production, and also a lot of the research that's been conducted that you heard about today was dairy research. In terms of, if you look at states that are major cattle feeding states in terms of corn silage production, I think the states that you pick out from that list are Nebraska, Iowa, and Kansas. And so just kind of pointing that out. So how do we stack up in terms of some of the good management practices that we've been hearing about today that are well known in a lot of the dairy states, and a lot of the silage research you heard about today come from Wisconsin, Michigan, and some of those dairy states as well. So to look at that, we did a survey last year, and again, Russ led that survey. I'm going to turn it over to him now, let him go through some of the survey results, and then I'm going to come back a little bit later and talk about some of the analysis, feed analysis that we collected from these producers.
Okay, thanks, Dan. Can you hear me? Is it on? All right. We better not stand up here together, Dan. We'll really blind people out there. But okay, as Dan said, we did this survey, and just a little bit about that. We tried to identify producers that we knew were harvesting using silage. We didn't get dairy people included. We would have liked to have done that. The dairy folks, my counterparts, they were on another project at that time, so they didn't participate with us, which was fine. So these were all mainly beef producers. But one of the questions we asked in the survey was what's on producers' mind. We got probably 40 questions or 40 different responses to that. We just combined those in kind of a word picture here. The big ones were, big words were the ones mentioned most often, but a lot of the questions that have been asked here today. So we're covering those topics that at least were on the minds of producers when we did the survey. A lot about efficiency, comparing different types of silages, earlage versus corn silage, storage losses, all those sorts of things. What's the best methods for covering piles? All those types of things were covered. As far as a little bit about the survey, we sent out about 300 mail surveys, got a pretty good rate of response to that. We also did it online, so not sure how many people saw it online, but most of ours were returned by mail. So out of the 110 surveys we got back, 78 represented silage harvest, 32 earlage. We'll talk a little bit about earlage here too. You can go through the rest of the data there and see how those people were using it. Again, we didn't have dairy people involved. We have a pretty good mix of feedlot cow-calf operations there. We'll talk a little bit more about size of operations as we go through here. Most of the earlage were primarily feedlot operations. Again, a little bit more on demographics. The survey would represent, of those 78 operations, about 10,000 acres of silage. We talked about total acres. It's about 3% of the total acres in Iowa. Don't know how many acres of earlage we harvest, but the survey represented about 18,000. And of those 78 surveys, again, from census data, we're looking at about 7,000 operations. That's beef and dairy total in the state of Iowa. So we had about a little over 1% of the total operators. And then did a little bit more work with the census there and kind of broke it down by acres harvested. And the state number there is kind of the census data said that's the percent harvesting those number of acres. And you can see on our survey data, we sampled a little bit of the producers harvesting a little bit more acres, I guess. So again, pretty good representation of the state in total, I think. So here's some of the responses we got to the survey. I'm not going to go through these in a lot of detail. I guess one of the things that I would point out is the range, a lot of these things. Average probably doesn't fit anybody, but we had a big range in a lot of these. We asked about acres. Again, average of 129 acres. If you look at the state, it's lower than that, probably around 56. We talked about those that planted a corn silage hybrid. About 30% of the respondents said that they did. We tried to look at that a little bit further. Was there any differences with those that did that? And we didn't really find any. That doesn't say there isn't any. We just didn't find any in our data. One of the things that you might look at your paper or your proceedings a little bit, I got a star beside it here on the screen. The harvest time per acre, it's wrong in your proceedings. Basically take them by, divide it by 2 in your proceedings, or you can write those numbers down up there. So again, that seems pretty slow, about 0.77 or 45 minutes per acre. I think he left here, but the guys were doing 600 tons in 8 days. They're going a little bit faster than that, I think. But it all depends on the equipment you're using, and of course, how many people you got working. We probably should have asked a question about man hours. We didn't do that. Like most surveys, you think about things you should have asked after you get the information back. But again, if you look at that range, it's a big range in there on the speed of harvest. We'll talk a little bit more about that one in just a little bit. We asked them about their moisture target. Most were there right around that 60, but we did have that range of 55 to 66. Then in addition to that target harvest, we asked them, where did you actually start harvest and when did you finish, if they had an estimate of moisture or an actual measure of moisture. So most of them started about where they targeted, but they were drier when they finished. And I think that'd probably be typical of most silage harvests as well. 60% of those 78 producers used a custom harvester, and 40% obviously were using their own equipment. Overall, 72% were using kernel processing. I think that probably surprised us a little bit that many were using kernel processing. Probably a good thing, but it's a little bit surprising. 58% were using inoculant. You can see the different storage types there, and we'll talk a little bit more about that by size of operation. If they were using a bunker or a drive-over pile, most were using a cover. We tried to sort through different cover types, but it ranged from plastic and tires versus oxygen barriers and all that kind of thing. Didn't try to put all that together for you today. On the testing part, this is probably a little bit disappointing that 40% said they were testing for moisture routinely is what we asked them, and about 2/3 were doing a nutrient analysis. And then target cut length, there were about 0.6 inches, 0.62 inches, but again, a big range, and we'll talk a little bit more about that in relation to kernel processing too. So again, a lot of range in all these things, and I'm not giving you all the questions we asked, these were some of the highlights. We won't go through all those numbers, but we just kind of broke down those practices by size of operation and how many acres they were harvesting. So again, as you look at silage hybrids, inoculants, all the way through, there's not a lot of difference in size of operation, at least in this set of data. So, again, the bottom line is what they were overall, what they told us as far as percentage. Probably some differences there when you get to the very large operations that were harvesting over 500 acres, but we didn't have many of those in the survey either. Then we looked at storage type, and obviously one of the things you see here is that the smaller operations were using more bags. 60% of those were using bags versus a bunker or a drive-over pile. As we got bigger, more bunkers and more drive-over piles, and that'd probably be more common for here in Nebraska as well. We did a little bit of work looking at those that use custom harvesters versus their own equipment. And again, a little bit of a trend as far as average number of acres toward larger number of acres using custom operators versus their own equipment. But again, the ranges were pretty large on each of those. Some small operators were using custom, so it wasn't necessarily all one. We looked at that back on that breakdown by acres harvested. And then again, on the harvest time, we kind of compared custom versus own equipment. A little bit of difference there, a little bit faster harvest with the custom operators. But again, those ranges kind of overlapped a little bit, so I'm not sure if that's real or not, but anyway, that's what the data actually was telling us there. Another one looking at custom harvest versus own equipment. A little bit higher percentage of those using custom equipment were using kernel processing. About the same custom or own equipment were using inoculants. And then on the target cut length, the custom operators, it was just a little bit longer cut length, but again, the ranges overlapped. Again, the big range on each of those. This one's a little bit harder to understand if you just look at it, but it gets back to that target moisture and where they said they started harvest and where they finished. And again, the top two lines are the overall of all of them. The bottom compares the custom to own. And I guess if you just want a quick takeaway from that, they were all pretty close to where when they started as far as what they were trying to achieve as a target moisture. And again, when they finished up, they were drier as far as the range. At the bottom there is a little bit of the actual sample data. So we only had 11 samples. We could compare back to the target moisture. And on average, those 11 samples were 6.5% drier than what they were targeting. But again, the range was 27% drier to 5.6% wetter. We'll talk more about the samples here when Dan gets up. So I wouldn't put a lot of weight on this type of stuff. There's just kind of some interesting things that I tried to pull out of the data. But if they were using bags or uprights, they had a little bit longer harvest time per acre. If they were, again, using a pile or a bunker, we looked at that harvest time, and we asked them about the time to pack. Average of 8 minutes per load. We didn't ask them what the load size was. We were trying to keep this survey within a couple pages, so we couldn't ask too many questions in there. But again, a large range reported there as far as their packing time. And I took a look at that target cut length if they were or weren't using kernel processing. The average was 7/10 of an inch with kernel processing and 5/10 of an inch without, which makes some sense. But again, we had that large range in there, again, on both of those if they were or weren't using kernel processing. On the loss, we asked them about what they thought they were losing. We didn't know, didn't ask them to try and measure that anyway. I think their Relative losses are right. Some of them are probably closer to the max than the average in reality, but you can see what they were talking about as far as losses. The minimum losses there, if we can achieve those, that would be great, but I'm not sure we can actually get that done. And very quickly then, this is just some of the same stuff on earlage as far as the acres and reported yield. Again, a little less time used in harvest, and you can change those numbers in your proceedings again if you want. That's what the asterisks are there for. Just divide them by half, basically, from what's reported in the proceedings there. And we talked about some of the moisture targets and where they started versus where they finished as compared to the target. 80% were using a custom harvester, 58% were using inoculants. Again, more larger operations, so more were using bunkers or drive over piles, but still some using silage bags for this. And about the same percent were covering those piles. And again, 2/3 of these guys that were using earlage were doing some moisture and nutrient analysis. So I'm going to switch back to Dan here. This was a part of the survey too, and we asked him about inclusion rates for different weights of cattle. So, and this will kind of lead into some of the sample analysis too. So, Dan?
Okay, thanks, Russ. A couple things I forgot to mention. So on one thing, so if you look at the number of acres that are of corn silage that are produced in Iowa and Nebraska, it's somewhere around 200,000 to 300,000. Wisconsin's our number one silage producing state at about 880,000, 890,000, something like that. But if you go back in the census to the late 1970s, both Iowa and Nebraska were about 900,000 acres. So it's you know, it's something, you know, as this opportunity grows in Iowa, we look at corn silage as an opportunity, and this was mentioned earlier with our nutrient reduction strategy and the movement towards cover crops, cereal rye cover crop following corn silage, nutrient management with manure. All of that really fits very well in a system for cattle feeders. And that's one of the reasons, in addition to all the nutritional reasons that you've heard about today and we'll hear more about today, is one of the things that we see some real opportunities in corn silage. So with that, just something that I'd forgot to mention earlier. Inclusion rates from Russ's survey. If you look at the corn silage, find the right button here, the corn silage inclusions, it runs from about 26% on the average for 4 to 6 weights. So these would be, this is average, and notice the range from 5 to 80%, considerable range. The finishing rations average about 11.5%. Earlage, it looks like that. In that case, earlage is used primarily at a relatively fixed rate, so not as much difference in the earlage inclusion rates. Russ, you can correct me if I'm wrong, but based on discussion earlier, when we are defining earlage in most of the producers in this survey, this would really be snaplage primarily, wouldn't you say?
Yeah,
according to the definition that was discussed earlier. So, and the inclusion rates for corn silage, I think this would indicate, Galen, that a lot of our producers might be looking at the UNL research on terms of inclusion rates. So the sample analysis is not a large number of samples, but we think it's enough to be representative of the producers that were in the survey. It's about 1/3 of the producers in terms of corn silage. 35 silage samples. 23 with the survey, 10 samples within each of those we actually did particle separation on, which is kind of interesting data even though it's not a lot of numbers. We had 20 earlage samples. Some of them had yields, and so we went back and looked at the silage to beef analysis from the software program that Garland has developed that we shared 2 years ago. We'll talk about that briefly, but really not enough numbers there to really share meaningful data. Russ attempted to make some comparisons. Again, I don't feel like we quite had enough numbers to make really good comparisons, but we wanted to look at, you know, differences in analysis, whether it was a silage variety versus regular varieties, whether or not inoculants were used, storage type, moisture levels, those types of things. We attempted to do that, but I'm not sure we had enough numbers for those to really be good, valid statistical comparisons. So I'm just going to share a few of these. You have all of these in your proceedings. I'm just going to touch on several of these. One of the first ones, this is the average, the minimum and maximum standard deviation of all the samples for corn silage. One thing I'm going to point out, for every single nutrient, there's a lot of variation. The other thing that I would point out, and I've always felt that the average dry matter for corn silage of beef producers is drier than what it would be for dairy producers and what might typically be recommended. I think there's two reasons for that. Some of it is that our custom harvesters harvest all the dairies first before they get to the beef producers. Some of it is that the trade-off between silage yield, nutrient yield, and nutritional value, it may favor the yield comparison for beef producers than nutritional value. In any event, our average dry matter was about 43, but that ranged from 30% to 60%. The crude protein, again, averaged just under 7, 6.8. The range from 5.5 to 8.7. So tremendous variation, or quite a bit of variation in both of those numbers. However, you know, if we take this, if we look at the digestibility, the starch content, you notice the minimum, I keep pointing up there, the minimum is 21%, maximum 48%, so this one obviously would be a grain variety. This would probably be a silage variety with an average starch content of about 40% starch. You can see these other values. Same thing with the fiber. Fiber averaged ADF 23%, NDF about 34%, but ranges from the low 20s for both of those to 30 for ADF, 45% for NDF, as well as digestibility variations in terms of NDF digestibility at 30 hours. So it's quite a bit of variation, but if we take that to the next slide here that has some of our fermentation values, actually the pH number averages about 4.5, 3.5 to 4, or averages 4, a range from 3.5 to 4%. It would indicate that the majority of these samples were good, you know, adequate fermentation from that standpoint. Question came this morning about driving off dry matter or driving off organic acids and how much of the energy value, Fred, is in the organic acids. There's a tremendous amount of variation in these particular samples. Whoops, ranged from, where am I? I lost it already. Right there, ranged from, if you just look at lactic acid, from less than 1% to almost 6% with an average of about 3. Total silage acids averaged about 5%. So these were calculated net energy values that you can see here. And these are pretty close to NRC values if you look at the average values. But in terms of the range, 66 to 79 for NEM, 38 to 52 for NEGs. If you use those numbers, quite a bit of variation. Bottom line, book values may represent something close to the average, but probably doesn't represent any individual sample. So we really would encourage all of our producers to analyze those. Similarly with our earlage samples, we see similar variations. Our average percent dry matter actually surprised me. I would have expected it to be slightly drier than this, but it averaged 66, but a range from 52 to 76. Again, crude protein averaged 7.9, but with a range from about 7.5 to about 8.5. So again, quite a bit of variation there. The starch, the range in starch was from 50 to about 65 with an average of 60. Fiber, look at the variation in fiber, and this is significant. And this is because earlage is quite variable in terms of the, and that may be where we get some earlage, some snaplage samples. You have a lot of difference in the amount of forage component that's in these particular samples depending on how it's harvested as well as the dry matter. But the ADF ranged from 5 to 12 with an average of about 6.8. NDF from about 9.5 to 25. So a lot of variation there. Let's see, where was that? The .04? We need to go back and check that. Russ, what do you think? Is there an odd number in, there must be an odd number in there or an error. Hey, Russ will check and we'll get back to you, Dave, yeah. Let's see. These are the earlage net energy values. Again, I think the NRC values are right in this neighborhood probably, but again, based on the calculated, primarily driven off the differences in fiber, a lot of variation there. So you want to be sure and know what the fiber values are when you look at those. And this is kind of wrapping it up here, but particle size. Particle size variation was huge, absolutely huge. So we actually did the high moisture corn particle size analysis on the earlage. It ranged from 1,600 microns to a maximum of 2,800 microns. That would be, as I recall, that's about like typical dry rolled corn in terms of average particle size, and the average here was about 2,100. We shook them down through the shaker box Penn State particle separator, and on the average, this is the corn silage analysis. If you look at our dairy friends, Penn State, what they recommend that good quality corn silage should be from a particle standpoint, you will see average numbers that are almost exactly like these numbers within those range. So on the average, particle size is about where our dairy friends would recommend good quality corn silage should be. However, the range is really, really significant, from 2.5% to 15% in the top tray and 25 to 53% in the bottom tray. That means 53% is very, very fine particles, less than 1/3 of an inch that would fall into the bottom tray in the particle separator. Earlage, even a wider range in particle size, ranging from 1 to 10% in the top tray, but the bottom tray, there's one sample that 85% falls in that less than 0.3 inches, and so that would be very, very fine ground material. So a lot of variation there as well. Why is this important? Depends on how you're using it. If you're, the finer it is, it enhances fermentation and so forth, but if you're using it primarily as a fiber source in a feedlot, then you definitely need to take that into consideration from an effective fiber standpoint. Okay, last thing, I think we're about out of time. The other thing we did, and this is in the proceedings, but I'm not going to share with it here, but those producers that had the analysis and had estimates on yield from their given fields, we calculated it, put it into this corn silage for beef spreadsheet. This is a free download from the Iowa Beef Center. This is basically, if you've seen the milk, Garland 06 analysis that basically University of Wisconsin has done that calculates milk production per acre. Garland has taken that concept and allows you to evaluate varieties on a beef production per acre. So it's a tool that's out there that you can use to evaluate silage varieties and other varieties. So what did we find? A few key points, and Russ can tell me if I miss any in this, but we didn't see a lot of differences in silage management across size of operations. I think we expected a little bit of that. We did see a tendency for the very large operations to incorporate more inoculants, do a better job in covering and that type of thing, but across most of the sizes we didn't see great differences. Producers really are adopting technologies that reduce storage losses and improve fermentation. So we're seeing, we're pleased with the adoption of some of those technologies. Overall, we thought those analysis that we were able to get from those producers were good quality, but there's a considerable amount of variation. And a lot of variability in particle size, and I think effective fiber potential from those, and I think more research is needed in that area. And finally, and probably most importantly, producers really could benefit from more testing, more routine testing to know what they have and how to deal with it. So with that, I'm going to stop and see if there are any questions.
Any questions for Dan or Russ?
Okay, their food coma kicked in.
Okay, let's thank those guys.